I'm just going to take you through a few examples just to kind of get you going on this idea, because I think experience is the best teacher when it comes to this, right? Or at least in my experience is the best teacher when it comes to this. So, and there are some things that you can rely on as you go forward. You start noticing that there are some similar problems that are occurring over and over again. So then you kind of rely on that, all right? But I also want to pay more closer attention. I don't know, grammar is not my strong point, as you probably recognize. Notation and how to represent a final answer is going to be probably more important now than it has been in years past. All right, so we want to pay careful attention to that too. All right, so Kate is saving to take an SAT prep course that costs $350. So far, she has saved $180, and she adds $18 to her savings each week. All right, how many more weeks must she save to be able to afford the course? All right, so it's what we call a simple linear equation. All right, simple as in it's only one equation. All right, there's no substitutions, no intense algebra. All right, but we do need to define our variables. All right, so we want to be looking through the problem first, identifying any constant values. So identify any constants. All right. A constant value is a value that doesn't change. So an unchanging value. Identify any variables. All right, those would be ones that do change. All right, the vary part of variable. All right, so it costs $350. That's not going to change. All right, that's a fixed amount. All right, so the cost. All right, she has saved $180. All right, now that's a starting point. But the amount of money that she saves is dependent on time. All right? So the amount of money saved will vary, so that's a variable, dependent on time. So amount of money saved and time are two variables. All right? So we would want to define those two variables. Let whatever equal this, let whatever equal that. So we got to keep that stuff in mind. Now, in a solution to a problem that I asked you to do over the regions, you wouldn't have to write all this stuff. This is note taking, but what we write next is stuff that you'll have to include. All right. So we would say it would make sense to use t for time. Let t equal the variable, that variable t would be equal to time. And then you could use whatever you want to represent the amount of money saved. All right, you could say m for money. Let m equal to the amount of money saved. All right. Now, time could be measured in different increments. All right. So we don't just say time; we say time, and then indicate the units. So time in weeks. All right. So that's the departure from what you were probably doing in the past. All right. When you created let statements, you probably just said time. All right. You probably just said money. All right. Now we have to be a little bit more specific. All right, amount of money saved, that's fine. I mean, if you want to put the number of dollars saved, that would be fine too. Either way, it's the same. All right, but time, because it could be measured in different ways, we'd have to indicate how it's being measured. All right. So what we would say here, just ignoring that fixed cost, that $350 for a second, let's just talk about an equation that represents her process. All right. She has saved $180. All right. So that's a starting amount. And she adds $17 to her savings each week. So that means that the amount of money that she earns would start off at $180 and increase by $17 multiplied by every increase in week. All right. So if it's only 1 week that she works, then she'll only increase her savings by $17. 2 weeks, she'll increase it by 2 times 17 or $34. 51, 68 and so on. All right. So that would be an equation that represents her savings. It's a linear equation. Now what you do with that is really up to you at this point. All right, bless you. Because you can solve this using an algebraic approach, but you could also solve it using Desmos. All right, so if I were to say, just in Desmos, y equals, I'll use y and x, 180 plus 17x, I'd get a graph. It's not going to show up on the home screen because it's got 180 as the y-intercept, so I'd have to zoom out a lot. Something like that. Like, we really got to get out there. But you could eventually see the picture. All right. I would want to know when this equation achieves a value of 350. So what I would do is I would just type in y equals 350, because y represents the amount of money earned, and then get to that intersection and find the x value of that intersection. So tap, and you'll see it would be 10. All right. So you could do it using Desmos. That's not a problem. When it comes to application questions, if you want to solve it using technology, I have no problem with that, because the purpose behind application questions or word problems is the setup, interpretation, coming up with the equations, the modeling. All right. It's almost irrelevant how you solve it. In fact, some of the questions that you'll be asked will be nothing more complicated than write an equation that could be used to solve this word problem, and don't actually solve it. Because that's not really the purpose of the question. Right. So if you're doing it by hand, though, we know that the amount of money should end up being equal to 350. So then we could just solve it the way we've always been solving linear equations. All right, subtract that 180. You get 170 is equal to 17t, because this cancels. And then divide out the 17. I'll shrink this all to fit in a second. And you get t equal to 10. All right. Let me just get this in there. And so algebraically, it's not that bad. It's not one of those crazy fractional equations that we were working with. It's something. It's either way. All right, but we would not leave our answer like this. They present a question in words. We give them an answer in words. All right. We're not going to like it when we lose credit for that on the test, but some of us have to learn the hard way. I don't enjoy taking off credit on a test, ever. I'd like, because there's a fill all option when I grade. So in the grade book, I can, for all the students in the class, I could say fill all with 100, and it would put a 100 down for everyone. That would be the easiest thing in the world for me to do. It would be so great to give everybody 100, never have to take off any credit. All right? So I absolutely don't enjoy taking off credit.
Do you shed a little tear across a little?
A little bit, yeah. Yeah, because it's like, oh, I didn't want, no, don't make me do it. All right, I gotta do it. It's always like that, it hurts. For the little things. I mean, you leave a question blank, you're on your own. I can't do anything for you there. But When it's a little thing like that, a notation thing, I feel terrible when it happens. So, nope, that's not a marker. So what we'll write is, it will take 10 more weeks. You could word it in a reasonable way. I don't want to go too crazy here. It will take 10 more weeks for her to afford the course. I think that's fine. All right. So again, questions given in words, you give an answer in words. I promise on a test I'm not going to give you 10 questions that are all word problems and make you have to write a sentence for every one of them. It'll take forever. 1 or 2 word problems tops. That's about it. All right. So it shouldn't be too much to ask for you to write a couple of sentences on a test. All right. Sentence fragments even. I'm not. I've already said it. I'm not really the best when it comes to grammar. So I'm not much of a judge when it comes to when other people mess up the grammar. All right, Dan belongs to a movie club in which he pays an annual fee of $39.95 and then streams movies for 99 cents each. In 1 year, Dan spent $55.79. How many movies did he order? All right, so it's kind of a dated question. I don't know too many businesses that follow this model anymore, but it is what it is. All right, so again, we go through, we identify any constants. We identify any variables, all right? So the constant value, so a constant would be the annual amount. So in 1 year, Dan spent $55.79. So you could say the annual amount if you want to use terminology, but you could also say the amount he spent in 1 year. All right, the variables. If you're going to write an equation, there should be 2 variables, an independent and a dependent variable. All right, explanatory response variable, input-output variable. All right, so what depends on what? The amount of money he spends depends on how many movies he orders. All right, so the number of movies ordered and then the amount of money spent. I was trying to think of a different way to word that because I realized that movies, money, they both have an M, and I wanted to use different variables. But what I can do, we can just go with X and Y. All right.
Yeah, what about like film?
Say it again.
Film?
Films, yeah, that's true. You do that.
Yeah, you could have.
So I'd have to indicate somewhere that we're replacing the word movie with films. It's kind of a weird thing, but the Regents kind of frowns upon you just changing their variables willy-nilly without you indicating as much. All right, so the number of films ordered, or I guess I could have let it equal N too, but whatever. So F and M for the money spent. All right. Now there does seem to be a little contradiction. It's not really a contradiction, it just feels that way, between the constant, which is the amount of money spent in 1 year, versus the amount of money spent by this guy Dan. All right, so in both cases, he's spending money. It's just one is the target amount, the other is the amount he's spending at any given time. All right. So, but the thing is, we kind of loosely use the term time because time is irrelevant in this situation. It's the number of movies ordered. All right. So, so this is really, again, the target amount. So just focusing on the equation, what I would say is, well, we got that fixed amount of $39.95. He's got to pay that no matter what. And then for every movie he orders, he's going to pay 99 cents. So 0.99 times the number of films, again, making that change to not get confused. All right. And that's going to equal, depending on the number of films ordered, that will equal the amount of money spent, all right, at any moment in or throughout the year. All right. So that's our equation. If we set that equal to 55.79, and solve, we get our result. And again, it's just a matter of how do you want to solve it. All right, do you want to use Desmos or do you want to do it by hand? It really doesn't make a difference in as far as I'm concerned. All right, or you could use the TI calculator if you want. All right, whatever which way. All right, I'll do it algebraically just because why not? In the end, that's usually the thing people need the most practice with. So, never hurts to do another run through on that. So, 55.79 minus 39.95. Oops. 1584. Divide both sides by the 0.99. Just gonna move some stuff up a little bit. All right, so 1584 divided by 0.99, and we're gonna get 16. So how many movies did he order? So answer the question the way they asked it. We used F for films. For some reason I went to a capital F here. I have no idea why. That's a point of emphasis. Make sure you stay with the same casing on whatever letter you're using. If you're using a lowercase f, stay with a lowercase f, because we're going to see throughout the course that uppercase variables mean something different than lowercase variables. All right. So even I make that mistake sometimes, and I'm lucky I caught it. All right. So we said films, but they said movies. We answer the question they asked. So we said he ordered, or we will say he ordered 16 movies. All right. So I'll stop it there. Riveting and stimulating. A painting company charges $250 base plus $16 per hour. Another painting company charges $210 base plus $18 per hour. All right, how long is a job for which the two companies cost the same? Costs are the same. So we have two companies. We'll call them Company 1 and Company 2. All right, in each case, we have the two variables. All right, so we start streamlining the process, because remember, I was saying that a lot of what I was writing is what we would call notes rather than part of the solution. So if we just kind of jump right down to business here, we would say, okay, we got a $250 base price and $16 per hour. That's going to give us a cost. All right, so we're going to let T equal time in hours and C equal cost in dollars. All right, getting a little bit more specific with the money here. All right, so our two companies are each involving the same parameters, some fixed amount. We have the cost here is equal to 250 plus 16 times the number of hours. And the cost over here is equal to 210 plus 18 times the number of hours. All right, let me just bring it in so you can see. So what they want to know is what the t value would be in order for these two equations to have the same cost. What they're telling us is that whatever this value is for C, it's going to be exactly the same as this value for C. All right, which means that these two equations are equivalent, or they must be, or there must be some value of t that makes these two equations equivalent. So what that allows us to do is take each expression and set them equal to one another. I can take this and set it equal to this because they're both equal to C. All right, since they're both equal to C, they'd both be equal to each other. You know, it's an old property. We didn't really talk about it yet, but it's something called the transitive property. You know, if A is equal to B and B is equal to C, then A is equal to C. It's also the basis of substitution. All right, it should make sense because if I tell you that two numbers are equal and then you have another pair of numbers that are equal to the first pair of numbers, then they should all be equal to each other. All right, so that's what's happening here. It allows us to replace one of the C's with the other expression. All right.
So do we simplify those two equations together?
Now we're going to solve, yeah. So I'm going to subtract off the 16t. We could have subtracted off the 18t. It wouldn't have mattered. It would have just created a negative. That would have been fine, though. So 2t would be left over. Then I'm going to bring the 210 the other way. So minus 210. And so we'll get 40 over here. 40 is equal to 2t. Divide out the 2, and you get t is equal to 20. All right, so how long is a job for which the two companies' costs are the same? The job will be 2 hours long. All right, now that was a little bit more intense algebraically, right? I think we'll all agree. It's not, in some cases you look at it and say, yeah, it's more intense, not difficult, but more intense. Oh, thank you. Appreciate it.
Also, I have another question.
Sure.
Is it okay if you, and I might have to explain this a bit, if you would write down like two variables, like you would write one for the each job for one of them, one for the other, just so you could like, because I sort of like having something separate and then when I put them together so I know like this is a variable for this cost and this is for the other, or does it have to be just two?
It should be 2 for the entire scenario. Otherwise, you wouldn't be able to do the substitution because then it would be like an apples and oranges situation.
Yeah.
So, if you don't want to do the algebra, you know, like I've been saying this all along. You don't know that you're interested in using Desmos until you see the thing that makes you interested in Desmos. I mean, I didn't use that exact phrase, but you get the idea. So maybe you look at this and say, I don't want to do this algebra. This algebra is crazy. So type in your original equations. You still have to come up with these equations. So this and this, just use x's and y's. So y equals 250 plus 16x. Type in y equals 210 plus 18x. I'm just going to go back to an ordinary zoom just by hitting the home key, and then start investigating to see where they intersect. All right. Now they kind of run parallel to one another, but there is a point where they merge. Once you get to that location where it looks like they're indistinguishable from one another, tap on it and a gray dot will appear. Tap on the gray dot and the intersection will appear. All right. So you would get the 20 without having to do the algebra. And the benefit of doing this is, because it could say, in this case, it says how long is the job for which the company's costs are the same, all right, 20 hours. It could have said, what is that cost? In which case, you'd have to do more algebra. You'd have to take that 20 and substitute it back into one of the equations and solve. That 570 is the actual cost for 20 hours worth of work. So the coordinates, the ordered pair, will give you the solution to both parts of this. All right, so there's definitely a benefit.